Today we're going to talk about the troubleshooting step for electronics and electrical device. We're going to see all steps that can be used in the troubleshooting of different electrical and electronics device. Let's start with troubleshooting. Troubleshooting is the process of finding faults in a device and get solution of those faults. So it involves finding the faults and looking for the solution so as to solve that faults. So we're going to deal with troubleshooting in electronics device like television, radios, computers, and other electronics and electrical device. So we're going to pass on all steps that you can use in troubleshooting as an electrical or electronics technician. First step is to get or gathering of user information. It means here you'll be needed to ask the user of that device how the device developed that fault, in order to get information that will direct you is a way to get location of the faults. Let's jump on step number 2. Step number 2 is to confirm the presence of the faults. It means here you are needed to verify that the faults existing in that device. Confirmation of the faults will help you to get the clear picture of the faults in the device, and this will guide you the direction of the faults, the direction of where and how you can locate the faults in the device, and also it guides the ways of finding the solution. Step number 3 is to make inspection on the main cable, the cable that take power from the socket or use it to supply powers from the socket to the device or from the extension to the device. This step is very important especially for device that does not turn on. So here you must look for continuity in fuse in wires of that cables. As you must focus on physical damage, like inspect for any coating in plug terminals, like checking for rusty and isolation issues. Step number 4, check if the rods get required power. This step involves to ensure that the components such as speaker, display receive the required power. It depends which kind of device or type of device that you are dealing with. For example, if you are dealing with subwoofer, it means you must check if speakers or display gets the required power in order to make it to continue to work well. Step number 5 is to conduct visual inspection on the PCB. Or video inspections means that through your eyes you are concentrating on looking the PCB components and trace to see if there's any damage that can be identified through eyes. Here we're going to check different issues like burn mark, smoke coating, burnt components, loose components, missing components, burnt truss, cold soldered joints, and the other physical damage. Step number 6 is to conduct continuity testing. By using multimeters, we are going to conduct continuity testing on different components that can be checked by using that continuity testing. So use multimeter to check the continuities of different components like diodes, fuse, transistors, transformers, trace wires, and other components, so that you can verify all components still work. Step number 7 is to power the PCB. In step number 7, which involves powering of the PCB, it means here you are going to power the PCB to find the way of powering your PCB and to check the flow of power or current through within that PCB. So it involves powering of PCB and checking how current flow within that PCB. Step number 8 is to check PCB component response. After powering your PCB, observe the response of the components within the PCB. The components that can turn on when power flow within the PCB, like LED diodes, if PCB have display, buzzer, motors, or other components which can turn on to indicate that current flow within that PCB. But it depends on your PCB if it have that kinds of components. Step number 9 is checking the power supply block, which involves making inspection on a power supply system and its components. It means you must inspect on you must make inspection on a transformer, regulators, bridge rectifier, diodes, and all power system of that device. Step number 10 is to check individual components. This step involves checking of all components present in your PCB to confirm that all components function correct, and tracing the voltage flow through all components, and to compare it with power required values. It means checking of individual components. It means confirming. It involves to confirm that all components function correctly, and to trace the flow of power in all components, and to try to compare it with the required power. Checking of individual component involves removing it from the PCB to check it separately from other components present in the PCB. Checking of components while still on PCB can be affected by other components or by power present in circuits and lead to the incorrect results. So that's why you're supposed to remove it from the PCB and check it independently or separately from other components in order to check it accurately. Step number 9 is IC checking. Integrated circuits. This involves checking and making testing of IC which present in your PCB. You can use IC tester to conduct IC checking, and you can try to use IC data sheets so as to check the proper replacement of your IC, and to be familiar with a particular IC so as you can have clear information of how you're going to test that IC, and to know all pin diagram function. Step number 12 is to reassemble all components and to test. It means now you are assembling. It involves to assemble all components and to turn on the device to check if the particular faults have been resolved or it can work well.